Let's learn a quick and easy way to graph some quadratic functions. Remember that a quadratic function looks like this format. A, B, and C are real numbers. B and C can be 0, but A cannot be equal to 0. If A is equal to 0, then this is no longer a quadratic function because the x squared part of it is gone. You also should remember that a graph of a quadratic function will always be a parabola. You should be able to look at the equation and tell if it opens up or down. And again, that's by the a value. If the a value is positive, then your parabola is going to open up. If the a value is negative, it's going to open down. You also should have an idea if it's going to be wider than normal or narrower than normal. Again, all by the a value. The larger the a value, the narrower your parabola gets. The smaller the a value or the closer to 0, the wider it gets. Okay? So here's the easy steps that we're going to use to graphing. Number 1, we're going to find the vertex. We're going to sketch in the axis of symmetry, which is the x value of the vertex. We're going to find 2 or more points on one side of the vertex. You might want to use the y-intercept if it's available. And then we find the matches to our points, and we are finished. So those are the steps that we're going to do. We're going to do 2 quick problems, and you should have it down pat. Make sure that your equation is in standard form. I would like for you to, over to the side, write down your a value, your b value, and your c value. Now, we're not using the c value, but let's get in the habit of writing that down. So 2, -4, and 1. Find the axis of symmetry. Your axis of symmetry is always going to be x is equal to the opposite of the b value divided by 2 times the a value. So in this case, that is going to be the opposite of -4, which is 4, over 2 times 2, which is 4, which gives me a value of 1. So x equals 1 is your axis of symmetry. If you want, let's just go ahead and sketch that in. Put a little dotted line in here. There's my axis of symmetry. Now my vertex is on that axis of symmetry. The x-coordinate of my vertex is 1. And to find the y-coordinate, I'm going to put a 1 in here and in here. So that's going to give me 2 times 1 squared minus 4 times 1 plus 1. So when I work this all out, 1 squared is 1, 2 times 1 is 2, minus 4 times 1 plus 1, that's going to give me a -1. Okay, so 1, -1 is my vertex, so I'm going to put a dot right there. I can look at my a value. It's positive, so I know my parabola is going to open up, so I've kind of got that in my mind. And my a is also bigger than 1, so my parabola is going to be a little bit narrower than what would just be normal. Okay, so now what I need to do is I need to pick at least 2 more points on one side. Since I know that this is opening up, I know that there is going to be a y-intercept here. So y-intercepts all have an x value of 0. So I'm just going to go ahead and write that down. And then I'm going to go back up here, and I'm going to plug the 0 in here instead of the 1. And you'll see that's gone, and that gives me a 1. So 0, 1 is my y-intercept. So now I've got 1 point over there. I need another point on that same line. So I'm just going to go over here and pick -1 for x. So I will put in a -1. I can go right back up here to where I did this work before. Take this out. Put in a -1. Okay, erase this work. Okay, so -1 squared is 1. 1 times 2 is 2. -4 times -1 is +4 plus 1. So that's going to give me 7. So -1, 7. So -1, 1, 2, 3, 4, 5, 6, 7. Okay? So there are those. Now remember that the axis of symmetry cuts your parabola right in half. So now let's just find the partners. This guy's partner, if this is one place to the left, his partner is right here, one place to the right. If this one is two places to the left of the axis of symmetry, then his partner is two places to the right. Okay, and then I'm just going to go ahead and connect these. Put an arrow on the end, and there's your parabola. Okay, and all the little parts that you can do. Remember that your vertex contains your maximum or your minimum value. Since this opens up, this is a minimum value. So the minimum value would be the y coordinate of your vertex. So we have your axis of symmetry, your vertex, your minimum value, your y-intercept, and another point. All right, let's try another one. Now you might want to pause the video and do this one yourself. Flip back and forth and check to see that you're doing it right. All right, so let's pause for a minute. We've listed our A, B, and C values. Let's find our axis of symmetry. X is equal to the opposite of B times 2 times A. So that's going to give me 2. X is equal to 2. We can go ahead and jot that in. Okay, and then our vertex is going to be, so our vertex is going to be 2. And then figure out what this is. Now be careful because it's negative signs on the outside. So it's the opposite of 2 squared plus 4 times 2 plus 3. So this is going to give me 4. This is going to give me 8. This is going to give me 3. So negative 4 plus 8 plus 3, I believe, is 7. Okay, so 2, 7. 1, 2, 3, 4, 5, 6, 7. We know, because of the A value, that this parabola opens down. Oops, I need to do that. This parabola opens down. All right, and we'll just go ahead and use our y-intercept. And if you haven't figured that out yet, your y-intercept is your C value. So 0, 3. All right, and then I need another point on that sign. I'll go ahead and use 1 to find that other point. Put an x value of 1 in there. So if I want to, I can just go right back up here and borrow this. Put a 1 in there. And that's going to give me 7, and a negative 1 is going to give me 6. So 1, 6, 1, 2, 3, 4, 5, 6. Okay, match up the partners. And there we go. And that's it. Pretty easy graphing.